Well, greetings, mathletes, and welcome back. Today we're going to be talking about trig functions, surprisingly, but we're going to be talking about them a little bit differently. We're going to be talking about their inverse functions, the inverse trigonometric functions. Now, the ones I'm going to focus on today are just sine and cosine. We've already seen how sine and cosine seems to link its wagon to, or I should say, all the other trig functions link their wagons to sine and cosine. So it's a good starting point, and I don't want to load too much stuff on you right before the exam. So we're going to be just doing the introduction to this, and all of the computations that we're going to be doing today are going to be coming from the unit circle. So you probably want to have your unit circle out if you don't have it out already. I will have one that we will be using for the lecture. And in any case, let's go ahead and get started. So first of all, before I engage the unit circle here, I want to make sure we understand what an inverse function is. So an inverse function, a function, let's make that a little smaller. Nope, too much. Come on, there we go. Okay, try it one more time. A function takes your value from the domain and it maps it to some y value, right? That's the idea behind a function. You have an input and an output. Okay, so an inverse function, right? And the inverse function, we actually, to denote an inverse function, we use a -1, and it looks like an exponent. It is not an exponent. It's in the same place. It's the exact same notation, but if that notation is on a function, it is not the same as an exponent. It's just a notation that it's an inverse function. But what an inverse function does is it takes the output value and tells you what the input value was. For example, if I have a function, let's turn it back on. If I have a function f of x is equal to the square root of x, right? So if I have an input for that, right, if I look at x equals 9, then I'm looking at f of 9, which is the square root of 9, which is 3, right? So that means it takes 9 and maps it to a 3. If we want a function that undoes this, that takes the 3 and maps it back to a 9, what we want, the inverse function of this, is x squared, right? Because squares undo square roots. So if I take f of the output, or f inverse of 3, that maps it backwards back to 9, right? Because I'm squaring it. And we see it more practically this way, right? If we're solving an equation, right? If the square root of x is equal to 3, we use a square to undo those things, right? And that gets us back to what x was. So we use them in the course of solving equations more than anything else, right? If you know the function's inverse, you can use that to solve an equation that involves that particular function. So what we're going to do is do this with sine and cosine. So let's see here. Let's do this. And get rid of this. Okay. So, for example, let's say I'm going to pick something that's real straightforward. If I look at sine of 30, right? Sine of 30, remember it's an x and a y value. Sine is your y value, and so that tells me that it's 1/2, right? So if I have an equation that says sine x equals 1/2, I should be able to work out that x has to equal 30 degrees, right? That's what it should be. But we have a small problem. There's more than one place that sine is 1/2, right? It's 1/2 here, but it's also 1/2 over here at 150 degrees. So how do you know which one it is? Well, here's what we do. It's actually been worked out, and those those angle measurements that are greater than 90 degrees, we're actually going to handle those things in the next lecture. What we do to make things convenient so that we have one and only one answer that comes out of this is we restrict sine to only the first and the fourth quadrants, right? So that means I'm looking at these sine values and I'm looking at these sine values. Anything that's over here on the left-hand side of this, right? All this stuff, I'm ignoring it, right? I'm completely ignoring it. I will never get an angle over there. So this is how we end up actually working this out. So the inverse of sine can be written two different ways. Most of the time nowadays, it's written sine inverse, right? And you use the -1 as an indicator that you're using the inverse sign. The other way that it gets written, and you see this more, well, you'll see it more in calc books and things like that, but you'll also see arc sine. And that means the exact same thing. The arc sine is the inverse of sine. So if you see arc before it, or if you see that, we're talking about an inverse function. And from what we found out here, right, if I took the arc sine, the sine inverse of 30, oh, not 30 degrees. Sorry, I'm saying it backwards. Of 1/2. What that's asking me is what angle gave me 1/2. What angle did I take the sine of to get 1/2? So what we're going to do is go up to our unit circle and look only in the first and the fourth quadrants and find a 1/2 in the y value, right? Because sine is y. So I have it right here, and I don't have any other 1/2 because all these are -1/2. And I get 30 degrees or pi/6, right? It depends on what it's asking you for, whether it's asking you for radians or degrees. So sine inverse takes the side ratio and spits out the angle instead, right? So that's a way of getting a hold of the angle when all you have are the sides. Okay. So let's go ahead and do this. And actually, let's see if I can, yeah, well, let's just take a look at a couple more of these. So if I wanted to compute, sine inverse of √3/2, right? What I do is I find a √3/2 in sine's position. It's right there. And then I look at that angle. If it's asking me for degrees, I can see that it's 60 degrees. If it's asking me for radians, I can see that it's pi/3 radians. So we're going to be doing this just from the unit circle right now. And it's just to give you a feel for what these things actually mean, because later on you actually have to do a little geometry with the unit circle when you start messing around with things that are bigger than 90 degrees, right? So right now, if we're talking about sine inverse, right, you can put, as far as the angles go for sine inverse, the ones that you're going to be dealing with, excuse me, all of your outputs are going to be from -pi/2 to pi/2, right? And that's this part of the circle right here, right? That's -pi/2 is at the bottom, pi/2 is at the top. So in thinking in terms of angles, that's the right-hand side of the unit circle, right? So this is going from sides to angles. Okay, now with cosine, it's a little bit different. And I want to go ahead and, well, actually, let's do one more example of sine just because. Let's say I have sine inverse of -√2/2. Right, so that means that I find a -√2/2. Here it is. And from there, I just trace the angle back. So that is 315 degrees or 7 pi over 4. Right? So these can be done on your calculator as well, but they don't give the nice answers in terms of pi. Well, I guess some of the calculators do nowadays. We have the better computer algebra systems, but yeah, it's going to give you a decimal for that. So as far as coming out with an exact answer in terms of pi, you need to be able to do it by hand. All right, so let's go ahead and take a look at cosine. Cosine's pretty much the same thing, but with some other slight differences. So let's go ahead and clear that off. Now, cosine is much the same. It's one of those things where you want to remember that y is your sine value, and theta, and x is your cosine value, right? Those are the things you want to remember. So with sine, we took everything to the right of the y-axis, and with cosine, it turns out the x-axis is our dividing line. So the x-axis for cosine, we are confined to quadrants 1 and 2, right? So this time we're dealing with the top half. So for cosine, we want to deal with the top half of this thing, right? So I won't even be looking at this bottom half. It's only the top half. All right, now, if we're going to compute some of these, it really is just a matter of matching it up on the unit circle, right? If I have cosine inverse of root 3 over 2, right? It's the cosine inverse, which means I'm putting in the side ratio and I'm getting out the angle. So let's find a root 3 over 2. It's cosine. Cosine is your x value. So let's just follow it around. And as I go around, I see I have root 3 over 2 right here. And that angle is 30 degrees, or it's pi over 6. Oops. Let's try that again. Right? It could be pi over 6. It just depends if you're asked for degrees or radians. You could be asked for either, so I'm doing both. If I want cosine inverse of negative root 2 over 2, right? What I do is I find negative root 2 over 2 in an x value. And let's see here, that's right there. And I'll just follow that angle back. So it is either 135 degrees or it is 3 pi over 4. Right? So you can work these out just by looking at the unit circle. What you want to remember as you go through here is that quadrants 1 and 2 over here, right? These guys are sine. Right? This is where sine functions. It's in the right-hand side. So if you're dealing with sine inverse, actually, yeah, this is where we deal with it. If we are looking at cosine, it's this part, right? So here is where cosine theta rears its head, right? So sine is to the right of the y-axis. Cosine is, well, north of the x-axis, I guess. So each one of them covers 2 quadrants. The only one you can trust both of them, where both of them are positive, actually, is in this first quadrant here, right? But you really, really, really want to make sure that you understand how these things work. Dealing with the quadrants it doesn't touch, there are ways of doing it, but we're going to do that in the next lecture. Okay? So hopefully that was clear. And it really is just a matter of matching things up right now. We are going to take a bigger look at this. And we're going to look at it in more detail. This is the introductory lesson for this section. So in any case, until next time, keep your pencils and your wits sharp.